Hi everyone. So in the last session, we have understood one of the real world application that is bus booking app. We tried to build it minimum way. Like in front end, we have used React.js and in the back end, we have used Node.js. And we have kept with these with minimum features like showing off available buses like how we used to see real world apps like Abibus and Make My Trip for buses and everything. And once you refresh those buses, we will get all the list of buses. And if we want to book any kind of like booking things, we can actually book. So the user who is using this will be limited to the UI, but the actual when a particular button is hit, when a particular refresh is made, when we search buses, all these things are behind the scenes. It is controlled by our backend. Backend is the combination of both our server and the database. The server where our actual application is being hosted and the database is actual where real world applications Amoeba's database is present. And these are the logs. Like in the last session, we also understood how we can keep all the logs, like for every user hit, how developers came to know the things performed by the user, whether he is authorized to do that one, how the response will come in the JSON format. Actually, this response and request, which all are coming from and back by the API in the JSON format. And those things we are combining together and keeping them in the logs. So this is how logs are maintained. For every log, we will maintain a trace ID. For every request, we will maintain one trace. So please check out this and understand how this application has worked. And you can go through this in the YouTube channel. And today's session is far more ahead of it. So we will be understanding what is a actual, this is the thing we have used. It's a local host. It is limited to our system. If any other, like if my friend want to use that application, want to see how output works, or else the person who is listening this want to know how actually I have built that application, want to explore, but they cannot do. Do you know why? It is because the current application that I have built, it is hosted locally. Locally in the sense when installing any Python software, any Node.js software, I'll actually get local server also where every running of my application will hit to the local server and it is limited to my system. It is currently running in my RAM in memory. So in this way, this is not just like we cannot use like I want. It's not how the real world applications works out. If you take google.com, it's not limited to like it works in my system only and don't work in your system. It is all over the world. Like they have made it available to all the users who are using google.com search engines. Abibus, you can take example because we are in the way of understanding bus booking systems. So let's start this from one local server, that is local host means our application, our computer, our PC, to production load balanced architecture. But when all the things come in this way, we will understand them clearly. So uh, by considering the last session and today's session, where we are today, we are in the local development part. In the previous session, we built a bus booking application, but currently the application is running locally on one machine. And your laptop's IP address is this one, and bus booking application is hitting this, and the database. Your laptop is the client, and it is hitting to the local server, that is one of the backend system, and the database. Generally, I'm limited to this part only in my application. So in real world, it doesn't work in that way. How we move this thought of local host to the cloud host, that is production, etc. Now imagine our application is deployed on a dedicated production server. Production server, the server which is actually hosting our application. We have internet where we will make requests to that server, and we have a public IP address where every request will be flow from here to the production server and database. DNS can resolve a domain such as abhi.api.abhibusdemo.com. So this is just my Abhibus public IP address. I am a user limited to using the public IP address of Abibus. Till then, I am restricted. After that, I cannot I don't know whether where my request is actually going, whether it is going to there are in distributed systems, there are multiple servers where my current application is running. So what is the need of it in order to make available? It should not if one server goes down, other servers will help in traffic management. All these things. For that reasons, my current application is running in multiple servers. And if we can see here, right, like in Abhi bus current users, it's not just one user, two users. There are around 30 million active users. These amount exactly to the 3 crore people who are currently using Avivers, and they are having multiple servers as well posted their things. Production does not mean zero downtime. There might be zero time downtime, but production systems are designed for high availability, reliability, and continuous operation. But individual machine can still fail. If you think that I'll make my laptop available by 24 by 7 and I'll host my application in my laptop, still the configurations won't help. It is a good idea up to an extent. After that, your computer as well fails uh, in terms of aging, etc. So, if initially if there are 100 users, then you can say like till here you got an idea, right? Why we need production servers? What is the use of them, etc. Like this is the surface level architecture I'm explaining, but the real scenarios, the real architecture will start from here. Consider there are 100 users. What do you say if there are 100 users? Then you can easily hit one server. If your application is like serving 100, only 100 clients, then it is okay to having one server, and it is reliably fast as well, and it will be available as well. But it is not at all guaranteed that it won't crash. There might be times when it can crash. Now imagine, like if you are running an e-commerce application like Amazon.com, there are around millions of users. Like before festive seasons also we need to have each and every day, if it is festive season the workload will be more, and the users will hit a long, like there are many multiple users, and 100 users will become 1 lakh users. Then it is not ideal of having one server and definitely our server becomes slow, and all the 1 lakh users face that downtime, face that particular slow in a response rate as well, and finally our server cannot able to serve at least one dedicated user as well. For that reasons also, like these are all the problems we are seeing, having one server versus like users, 100 users versus 1 lakh users and workload. So after that, for every like we can say for every user action, like uh, user action perform actions in the UI, there is something server is doing, there is something our backend is processing things. Then CPU can become overloaded, RAM can become exhausted, network capacity, database connection can become exhausted. All these things or the request and response time will definitely starts failing. These are the some of the like problems that we see when we are having one server, 100 users versus 1 lakh users hitting at once. Consider three scenarios. Like we have understood like why we are considering multiple servers instead of one server, like what problems it can solve. For that, you will get load balancer where it will be having multiple backend servers handling traffic. Sorry. So scenario two, web server. So static resources such as HTML files. And scenario three, reverse proxy. The client talks to one public endpoint instead of directly knowing backend servers. For that reasons, we can use reverse proxy. So these are just the three scenarios where in most of the time you might be known that load balancer, web server, and reverse proxy, all three are the same, but they are not. So let's decode one by one, and I'll make sure that by the end of this session, you definitely will be amazed by their individual performances, their individual roles and responsibilities, and you will get to know many things in this journey. So stay tuned, guys, and let's start the load balancer. The load balancer is like a decision maker, like uh, coming incoming request to which server I need to proceed. Like we'll be having users, and there is one public endpoint that is load balancer, and we will be having servers, and my particular application is hosted on multiple servers, and load balancer log for our load balancer as well will be having the logs. So once I send the request goes to the server one, and the IP address of that uh, server is 10.0.1.1. So our request is hitting to the first server. So it is first our load balancer checks whether my server one is healthy. It will for every periodic times it will get whether health checks it will get of all the servers it is considering for current application. And if I get 5 requests, so request 2, it hits to the server 2, then server 3, then again 1, then again 2, then again 3. So when I hit this send request, it first request is when, and again I have sent 5 requests. 1 plus 5 is 6 requests it has been made, and it is currently following round robin load balancer. And I have told that like for some reasons I got to know that my second server is not healthy. So I'll stop second server. You can see here server 2 is now down. Health check should remove it from routing. So all the request never goes to my server 2. Load balancer is like it is designed in such a way that it is always getting all those health checks. And I have seen that my current server 2 is now down. Health check should remove it from routing. And later I thought that like it has been recovered its state. Then you can see, you have seen, right? Last it was red and now it has become green again. You can see the logs. These are the logs of load balancer. Server 2 is healthy again and can receive traffic. Now the health check. The health check button will check all the servers health check. Once it gets 200 okay, then only our load balancer will route that particular request to dedicated server. You have understood, right? Like how a load balancer works. Now let's move on to the round robin. The sleep, like one of the algorithm of load balancer is round robin algorithm. As you can see, first is it has chosen server 1, then server 2, then server 3. Then server 1, it is round. You have seen the pattern, it is like round, circling. It is never ending circle loop it is getting. You can see here, it is one of the simplest load balancer algorithm where request 1 goes to server 1, 2, 2, 3, 3. Then again 4, 1. Again, the pattern is repeated. For that reasons only it is known round robin algorithm. The load balancer maintains an index and moves to the next in healthy server. Round robin algorithm always uses the counter index. So for this is one of the most used algorithm in our day-to-day lives, like all the applications. So I'll take a pass here and go through if anything like you didn't understood. And we can see like server 1, server 2, server 3, server again it is repeating. So do you see any defects of using round robin? Like it is considering all my servers are equally handles the request. Like server 1 can handle two requests, like as of here in the picture, server 3 can handle two requests. But what if my second server is not able to that much not computationally strong? I have made the infrastructure of my second server computationally low. Then round robin is not the ideal one. So we have other algorithms as well where we can see weighted round robin where powerful servers receive more traffic. Like earlier we have discussed, the disadvantages of round robin can be done by the weighted round robin. Then we have least connections. So the server which is having least connections, we will route the traffic to that server. And we'll be having one more algorithm, IP hash or consistent hash. Request associated with a client we tend towards the same backend. So these are the algorithms, and we will understand them clearly in our further sessions as well. And we'll be having the health checks. What happens if server 2 crashes? If server 2 crashes, then we will get from server 2, like as load balancer, keeps the tracks of healthy checks of each and every server. And periodically, each server will give their health status to the load balancer. Then server 2 is like it is crashing, and load balancer gets the information like, hey bro, I'm failing, I'm not able to proceed further. Then load balancer will keep server 2 down. Then the request will only goes to 1 and 3, 1 and 3. So this is the endpoint where health checks. So you have understood one more thing here. For every request and response as well, for every status, health checks, everything, the data is transmitted. They will talk to each other. How load balancer and its associated servers talk to each other through the JSON format only. So it is the universal lightweight format, easily understood by all others. The load balancer can periodically call /health on backend server and maintain the healthy server too. It is like code which is running, code upon code, which helps us understand things. Our application having code is different, but this is the load balancer health checks load. Oh, so you understood, right? How a health check is made, what is meant by load balancer, what are the different types of load balancer, what are their like drawbacks, and we will clearly understand the different types of load balancer in our further sessions as well. And let me tell you one, let's move on to the web server. Web server, it is like which is having our static files which makes our index.html, style.css, app.js, slash logo.png. Like if I tell you I want Abhi first, I'll tell you one thing. So these are static resources. The things are fixed, they cannot be changed. And the dynamic request that you make is by hitting something, doing some application thing. I'll search buses and I can see there are multiple buses. Just I'll select Hyderabad to Bengaluru and search. And I'll get some bunch of application. These responses, I'm just searching buses. These are everything they have kept in the web server. So if I make view seats, select seats, and if I select anything, okay, I'll select the boarding point, and if I select this, once I do proceed, and I will get one of the login applications. So it is asking me to authenticate. What do you see here? It is like hitting backend once you click on proceed. The These are the buttons. These are just the UI page is this one. And the actual backend thing, like you can also see through the inspect, the front end part, the UI, layout, everything you can see here. But the actual when you hit on next, when you hit on proceed button, you will get to know that is dynamic for each person. They can make changes according to them. Those are dynamic application requests. Software such as NGINX, Apache, IIS can perform web server responsibilities. So I'll tell you one more thing. NGINX is one of the most software. It's a software and it can perform all three things. It can be act as load balancer, it can act as your web server, and it can act as your reverse proxy as well. So you can understand reverse proxy. Without a reverse proxy, client must know server 1, IP address server 2, and server 3. All the backend servers it should know. So it is good way like client know what is the problem here. If I say if any person in the middle tries to compromise client, then Or servers as well, they will compromise because the anyway client is directly hitting to the server, and all our backend also will crash, will be like compromised, and the attacker knows its sensitive data the client is making. For that reasons, we will say one thing: hey, I'll keep something in front of client and the backend server. That something will act as the my endpoint. Like client only knows till this point. This is the public IP address. Till here, I'll be known. And after that, how this reverse proxy will make a request, how load balancer works, everything is hidden in the engine. So this is the softwares we will use in real world, which act as the reverse proxy as well. So if you don't understand, I'll tell you once again. Reverse proxy, it is like sitting, it is like the endpoint which hides your client from the backend and backend from the client. Backend should not be like client don't know which server its request is going, and backend should not be known that these particular server from these particular IP address it is getting. It will only come through the public IP address, that reverse proxy IP address known to the client and known to the backend server. And handling those requests to correct user, that reverse proxy will take care of it. Client only knows this. Client doesn't know the we have three distributed servers for Abibus. We have four distributed servers for Amazon.com, like that. It don't know. So what is mean by public IP versus private IP? Internet public IP, that is our, either it may be the load balancer IP address, either it can be a web server, either it can be reverse proxy. All these IP addresses, those are public. Once the request reaches to your public IP address, and the client only knows these public IP address, it not know the server ones, which is private IP, server 2, server 3 in the same way. So our powerful thing here is engines. One software can perform multiple things, like how a household coordinator works, handles guests, coordinates household tasks, directs requests to the right person. In the same way, engines can act. It can serve your static files. It can act as load balancer. It can act as reverse proxy. All these things. The configuration part is, you can see here. We will say like, hey, I'm for like bus backend, like Abibus, I'm having these three servers, and the server should always listen to the port 80 backend. And please let me know in the comments that what is the server like listening 80 port number, uh, which backend language it is using, and the location it will share, the proxy, that is reverse proxy um, link also we will be giving in our engine's configuration. In the same way, like, you have understood, right, how an engine works, how powerful it is, and you by now you might be getting all the ideas between you can able to differentiate what is load balancer, what is engines, and what is an engines, yeah, correct, and what is web server, and what is reverse proxy. It's the one person handling all the responsibilities. And we'll be having API gateway. API gateway is like, it's a starting point. It is like watchman. He, like, if you don't know, you will just directly go to your college and you will ask like, where can I go this way. There will be a person who will route your request to dedicated API, to dedicated, like if it is booking API, if it is get searching users, if it is payment API. it will route API gateway routes to concerned API. API gateway can provide all the authentication part, authorization, logs, everything will right here only. So complete production architecture, user hits the request to the internet, like if someone is browsing there, and you will be seeing the DNS. If I give abibus.com, the DNS knows the correct IP addresses of Abibus, which is stored in the form of key value base, where is the domain name and the value is its IP address, where browser knows can reach to that particular IP address, and it will hit 203.0.113.10. And here the request like engines come into the picture and does its response role as a web server if the user is asking static files, if the user is hitting some like backend thing like performing some task, post, proceed, payment, etc. If the user is every time the client is hidden from the backend and backend from the front end. So API gateway will reach us to dedicated API server, and then at low level of our work, the request reaches to the database and data will be fetched from there. In real booking request, if I click on imagine the user clicks book seat A2, then the actual flow will be this. Post API/booking. I'm booking A12 seat and the client will goes to the public IP address and it will goes to the load balancer. It will select load balancer will select the server based on the algorithm we have used there. Then private IP will be known to load balancer only. Then some booking validation is done in the backend controller, and then or services business logic will be ran. Then database call will be made. We will get a beautiful message that booking is successful, confirmed, status as confirmed. So this is the trace ID. For every request of user, a trace ID is created. What is the use of trace ID? Actually, trace ID we will use for logs. If an user made some request, like there is some halt, like he is not able to perform some task which he can do, like he has raised, for example, we will take Amazon delivery. We didn't get our order within a time span they have given. Then with that trace ID for that request, the user can talk to the customer service, and customer service in backend they will trace with that the help of trace ID. They will trace what went wrong in the backend. So for these reasons only, customer service is uh, very much important for all the applications. uh, Whatever the applications we will use, they'll be having huge budget for customer service as well. So that these customer service will route uh, the problem to their team leader if it is critical. Then the developer will come into the picture if anything needs to be done from them. The trace ID, these will be the same from uh, overall the rotation of client until their request crosses the server. If something fails, the trace ID helps us investigate where the request went and which component produced the problem. So We will understand here. Click the button repeatedly and watch round robin select healthy servers. So we are having here uh, request 6. I'll send request. Now request 7 trace ID has been changed, and this is the browser like request I'm making hits to the public IP, goes to the load balancer. Server 2 has been selected as of now. Application database. In the same way, server 3. You can see all these trace ID for every request has been created. And if I click send 5 requests, so request from earlier it was 9 I think, so now it is 5. Once again I'll click so that you guys can see from 14 it is 19. In the same way, like different servers, their trace ID, it will select. So interview questions. I want you guys to give me these answers in the comment section. We'll be seeing what happens if server 2 crashes. What do you think, guys? If server 2 crashes, then load balancer obviously gets health check as it is red signal. Then load balancer can make that server down and other servers in the picture where traffic will route to other servers other than server 2. The health check detects that server 2 is unhealthy and the load balancer stops routing normal traffic to it. Does the browser know the private IP of server 1? What do you think, guys? I think answer is no. No. In this architecture, the browser communicates with the public facing endpoint. The internal backend addresses are handled by the infrastructure. Why do we need multiple servers? We need multiple servers. At the start of our session, we have understood why we need multiple servers, because what if there is a festival season and our one servers cannot able to handle it, so it has been crashed. So instead of like it was good handling 1,000 users also, but because of 1 lakh users hitting jumping on our application at once, not even a single person able to use my application. So server crashes. In order to make availability and fault tolerance, what and all the problems that we have faced for that reason. Is Nginx only a load balancer? No. Nginx handles multiple depending on configuration. Nginx can serve static content, act as reverse proxy, and perform load balancing. All these things are actually done by the Nginx. It is a software where it is like registering my application there. It is you work as my reverse proxy, you work as my static content for web server. These are the dedicated rules that Nginx does. How can we trace one request with the help of trace ID? Use a trace ID and propagate it through the components handling the request. So the bigger picture is that internet we need our once internet is our google.com. Once I'll browse some application like abibus.com, the DNS gives its IP address and public end. That is the endpoint. I will my request goes to there. Now based on my request, it will does. Like if it is just like show me the amazon.com. As you can see, I'm not signed in to the Amazon, but also I can see these applications because this is the static. This is giving by my web server. In the same way, if it is web server, it will act like that. If it is reverse proxy, then it is like hiding my things. When I'm performing something, then reverse proxy will come into the picture. If it is load balancer, of course my request will move to that particular. It will route to dedicated servers with the help of different algorithms that we discussed earlier. And health checks is one of our important point here. And then we have API gateway will route our request to dedicated endpoint where if it is server 1, server 2 or server 3 at any moment the load balancer has been selected, and one user request for every user request will be having trace ID, healthy checks, application, database response. We didn't introduce a load balancer because load balancers are important. We introduced it because our original architecture had a problem. The problem of using one server, the problem of handling loads, the problem of scaling. All these things are necessary for us. Problem, scale, failure, solution, architecture. So this is our final bus booking system, web server, reverse proxy, load balancer, API gateway, distributed system. We have seen with just one server to production load balancer architecture. So thank you guys. Like I hope this session make you understand things a little more and confident than earlier you were without understanding them. And I would like to know the things that are concerning you in our comments or as in our community as well. I'll paste the link here as well and join the community and let's understand the things. Let's decode. I need your support as well in this. And of course, guys, let's do it. And I'll be coming with amazing sessions further as well. And please let me know on this.